Hello, welcome to our first video lesson of the year. We're going to start things right off with a lesson on decimals and place values, and we're going to base it off of 3.1 in our book. This is the first lesson in our very first unit using the Common Core State Standards, and the standard that this one is going to address is NS.3, which is fluently add and subtract multi-digit decimals using a standard algorithm. So as we get going, we're going to learn about what our place values are and what our how to read and write decimals. So the first thing we're going to do is look at these diagrams here, and these represent the manipulatives that you've probably used in the past. When you have a full sheet of squares, it represents the unit 1. That's a whole number. When we get just the line, you get a skinny line, that represents 1/10, and when you just get one of the squares out of the whole block, that represents 1/100th. So using base 10 pieces, let's complete these statements. 1 equals how many tenths? So this equals how many of these? Well, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines, so a whole number equals 10 tenths. Whoa, do I need to change the thickness there? Let's go down to that one. So that equals, we'll try that again, 10 tenths. 1/10, so one of these, equals how many hundredths? How many of these? Well, again, how many little squares make up a tenth? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So again, 1/10 is the same thing as 10 hundredths. Ooh, how about this one? How many hundredths, so how many of these is the same thing as this? Well, I'm going to save you a little time here. We've got 10 of these. If we were to count it out, there should be 100 hundredths in a 1. And then how about here, we're going to get a little tricky. If we have 2 of these and 5 of these, how many tenths does that equal? Well, we know we have 5 of them. But then we have 2 of these. Well, let's look. A single 1 equals 10. So if we have 2 of these, that means we would have 20 in our whole 1. And we have 5 in our tenths. So we get a total of 25. So 2 and 5 tenths is the same thing as 25 tenths. We can play with the manipulatives in class if we need to look at this a little bit more. But for right now, we're going to keep going. All right, so expressing a number in different ways. What they want to do is write 20 hundredths using only tenths. So 20 of these little individual squares equals how many of the longs? Well, we know that 10 of these equals 1 long. So 2 10 hundredths. So that would be the same thing as having 2 tenths, 2 of the 1/10 blocks. So our answer is 2 tenths is the same thing as 20 hundredths. When we use 1 and 4 tenths, we have a whole and 4 tenths. We only want to use tenths. We remember that the 1 is equal to 10 tenths and 4 tenths. We have 10 tenths and 4 tenths for a total of 14 of those long, skinny tenths. That's kind of how they're breaking things down here. So can we do this on our own? If I have 500 hundredths, so that means 500 of these, how many tenths would that be? I'm going to give you a second to figure this out, so you might want to pause. All right, when we come back, 5 hundredths is equal to, I hope you came up with 50 tenths. When we have 500 of these, 10 of them equals 1 of these. So for every 10, we get 1 of these, which means we have 50 tenths. Again, over here, 4 ones and 9 tenths. So we have 4 of the whole big blocks. The whole big square like this that had all of the little tiny squares in it. I can't draw that, but remember these equaled 10 tenths. There were 10 of these that made up the big square, and 9 tenths. So how many would that be for just tenths? If I don't want to count the as ones, I want to change these into tenths. I hope you would realize that we should have 49 tenths when we do that. All right, let's keep going. What's a digit and what's a place value? A digit is actually the number, and the place value is where we put it. So you learned your place values, that we have a decimal here that separates the whole numbers from the decimal parts. And when we go up in the whole numbers, we start at ones, and then we go tens, hundreds, thousands, 10,000s, 100,000s, millions, and then it starts over again, 10 millions, 100 millions, and then it would go to billions, and so on. So they go up by powers of 10. In the decimal side, again, we have tenths. It's just like this side, except we skip the ones. There's no oneths, but it's a mirror image of the rest. So it goes tenths, hundredths, thousandths, and all of these have the THS on the end. So it's almost like you're kind of spitting when you talk. Please don't spit, but that's kind of how it goes. So what's the place value of each digit in the number 18,245? The 5 is in the ones, the 4 is in the tens place, the 2 is in the hundredths, hundreds, make sure you're enunciating here, the 8 is in the thousands, and the 1 is in the 10,000s place. So we would write it out as 18,245. Notice I did not say and. I didn't say 18,245. We only get to use the word and when we're talking about a decimal point. So how is each value related to the place value to its right? How many times smaller or larger is the thousands place than the tens place? So that's just what we talked about here. They're powers of 10. So this is 10 times that. This one is 10 times the one to the right. So 10 of these would equal one of those. 10 of these equals one of those. It's called a base 10 system. So let's keep moving on. All right, so we have a person timing your swim meet says your time was 28 and 6/10 seconds. We need to learn how to write that as a decimal. When we see it in words, we always know that the and, whoops, sorry, I don't know what's happening with my pen there. The and means our decimal point. So when we have 28 and, that means we have a whole number part and a decimal part. So the 28 is going to come before, so 28 is our whole number, and 6/10 second. Well, we need to look at our place value. Tenths is where we know that's our first position, so that's where our 6 is going to go. So 28 and 6/10 seconds would look like this. We've got Buddy Rice won the 2004 Indianapolis 500. His best leading lap time was 41 and 6,913 10,000 seconds. Write his time in words. So I just read it to you in words. How I figured that out was here. This is our and splits it in half. So we get that in there first. That's what I always do, is put my and in to begin with. This is still a little bit thicker than I'd like. So I look at what comes before the decimal point, 41. So that's when I write out 41, F-O-R-T-Y -O-N-E. So 41, and now I need to work on this last part. I write this just as I would say it if it was a whole number. This would be 6,913. So I write 6,000. Oops, I got that a little close together. 6,913. And then the last part is to find that place value. I need to count it out. That's what I do in my head. I go, ooh, tenths, hundredths, thousandths, 10,000ths. So that's what I need to tag on here at the end, putting 10,000ths to show what my place value is. And make sure that you, when you say it out loud, that you emphasize the ths at the end, and make sure that you write it when you write it in words. So our last one, we learned how to take it from words and put it into a decimal. This is how you take it from a decimal and put it into words. So now we're going to get a little practice with that. Here's a little puzzle I'm going to have you do on your own. It says my place value is less than 10 thousandths but greater than 10 thousandths. So that means it is going to be less than this place value but bigger than this one. So that cuts these ones out. These ones aren't in the picture here. So it's somewhere between thousands and thousandths. It says the number of letters in my name has a digit in the ones place and a digit in the tens place value, but they are not the same. Which one of these am I? So you have to figure out how many digits are in the name. How many, when you add up the letters, what's that digit, and then figure it out. I'm going to let you do this on your own, so you're going to have to pause it and come back to this one. Here's the last part we're going to do. Write the amount as a decimal part of a dollar. If you have 6 dimes, the great thing about a dollar is just like our manipulatives. A whole dollar is like a 1. Our dimes are like tenths, and our pennies are like hundredths. So when we want to figure out the decimal part of a dollar, if I have 6 dimes, I have 6 tenths, 6 of the long, skinny manipulatives out of the whole. So 6 dimes would equal 0.6, 6/10 of that dollar bill. I want you to figure out what 3/4, 8 nickels, and 29 pennies are, and we'll discuss this as a class. Thanks for hanging with me with my first video lesson, and I'll see you in class. Have a great night.